Hi everyone, Mr. Eric Kwa here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic.
Okay, everybody, let's look at this question about the yield of the Haber process basically. So which diagram best represent the percentage of ammonia formed at different temperature and pressures? Okay, so one thing we need to understand, right, for Haber process is that it is a exothermic reaction. You need to remember that. So for Haber process, the exothermic reaction. So what this means is that the higher the temperature, right? The higher the temperature, the lower the yield of ammonia. The lower the yield of ammonia. So the percentage yield will go down if you increase the temperature, right? But for Haber process, the higher the pressure, the better the yield. Okay, this is because of the mole ratio. Okay, so these two things you need to know, right? You basically also need to know the equations. So you have 3H2 plus N2 gives you 2NH3. So 6 atoms of hydrogen and 2 atoms of nitrogen. So on the left hand side, right, you have 4 moles. On the right hand side, you have 2. Okay, so for O levels, right, all you need to know is that if you increase the pressure, there is going to be more ammonia formed. Okay, so now let's look at the 4 diagrams, right? Which one actually best represents the percentage. So we need to focus on one thing at a time. So remember, right? Let's look at A, right? When you increase the temperature, the percentage of ammonia yield goes down. Okay, so this is true. At a higher temperature, you get a lower yield. Okay, fine. But if you look along the pressure, right, as you increase the pressure, as you go to the right, what should happen to the percentage? The percentage yield should be going upwards. So as they are sloping downwards, we will not consider A and also B because they are both sloping downwards as you proceed to the right. Okay, so we're only going to consider C and D, and then we see that, okay, so they are both sloping upwards. Okay, sloping upwards as you proceed, have more pressure. Okay, both are okay. But now how about the temperature? Temperature says that the higher the temperature, the lower the yield. Higher temperature, do we have lower yield at the same pressure? Let's see. Let's say at 10 times 10 to the power of 3 kilopascal, do we have more percentage yield? So this is wrong, right? This is wrong because at 500 degrees at the same pressure, you have more higher yield at higher temperature, which is wrong. So it's wrong. D should be the correct answer. All right. So that's how you work out for this kind of curve involving Haber process.